Hello and welcome back to Hidden in the Stars. This episode's topic is a very interesting question asked by our awesome viewer Vince. Is the universe infinite? In order to understand the question of is the universe infinite, you first have to understand that this is a question that has many theories for potential answers. You must also understand that there is a difference between what is known as the observable universe and the entire universe. The observable universe is just that, what we can observe or the portion that we can see. We've measured its diameter to be roughly 93 billion light years. For a little scale, let's remember how big a light year is. 1 light year is equal to 9.461 e15 meters. 1 meter is equal to roughly 3.28 feet. Let's think about this. Just over 3 feet, not quite 3.5 feet, is 1 meter. Let's just say 9.5 to imagine it easier. So 95 with 14 zeros after the 5 of those meters is equal to just one of those 93 billion light years. 93 billion is 93 with 9 zeros after it. Can you sort of imagine how large that number would be in meters or even feet? Take not quite 3.5 feet, 95 with 14 zeros after it, times 93 with 9 zeros after it, times. That's how wide the observable universe is from end to end. That's not even the entire universe. We know that the universe is expanding because we can see the space between galaxies is increasing. We also know that the universe is accelerating in its expansion. I believe I misspoke and previously said the cosmological constant is what determines the shape of space. I do apologize. The correct variable is the curvature constant, lowercase k. If k is positive 1, it represents a closed universe or a spherical one. If k is 0, it represents a flat universe, also known as a Euclidean universe. If k is negative 1, it represents an open universe, which is shaped like a hyperbola. So it's curved in a U-shaped, a Schaff U-shape, if you're unfamiliar with what a hyperbola is. The curvature constant k appears in the Friedmann equations. These equations were derived to describe the expansion of the homogeneous and isotropic universe. This takes place within the frame of general relativity due to the fact that they are derived from Einstein's field equations. It's really quite interesting. Aside from the Drake equation, the Friedmann equations are my favorite to play around with. You should give them a quick look if you're not spooked by numberless equations. Current measurements suggest that the curvature constant k equals 0, or that we live in a flat Euclidean universe. Hold on a second. What if we live in a multiverse? One of those things we've seen where the universe is a sphere amongst spheres amongst spheres, or a chain of infinite Big Bangs. What if we live in a black hole? Haven't you heard Dr. Tyson lately? Just a second there. I got this. There are a lot of theories on this. The universe could be flat and finite. It could be flat and infinite. If it is flat, why would it suddenly stop? Like a disk? It's most likely infinite if it is, in fact, flat. Here we go getting interesting. It could be curved and finite, meaning that it would have to have a positive curvature, making it a sphere. This would make it finite, but it would not have a boundary. It could be curved and infinite, meaning it would be the opposite, having a negative curvature like the hyperbola, and would be therefore infinite. Finally, as you've been waiting for, the multiverse. The shape of the multiverse is unknown. This is because it's still a theoretical concept. However, there are theories on the structure of the multiverse. These are things like those bubble universes you were worried about, a quote, infinite patchwork, and ideas that are simply referred to as higher dimensional. These bubble universes are where the Big Bang is an event that can happen repeatedly to create there's that word, multiverse, of many of these bubble universes, each of which could be fundamentally extremely different, sometimes unfathomably fundamentally different. This so-called infinite patchwork takes the idea that the arrangement of the matter must be repeated at some point, which means identical universes with identical copies of everything inside these universes, down to the DNA of its inhabitants, could exist. Also known as parallel universes, the patchwork that they're arranged in is like an infinite patterned quilt. Higher dimensional ideas just refer to the ideas that things may be a part of a larger reality. If you feel like going down the astronomy rabbit hole and finding conspiracy theories, or if you just need a reason to be up until 3 a.m. death scrolling, or if you just really want to mess up your mind so every time you make the slightest movement you think in depth about the meaning of life and the mechanisms behind that movement, go digging up higher dimensional ideas pertaining to the universe. Suddenly, every atom in your life has significant, yet no meaning. Good luck. Lately, a lot of weird ideas have been thrown around in the world of the stargazers. Some astrophysicists are certain we live in a simulation, some know that we do not. Some think that we live in a multiverse, while others aren't so sold on that idea. Some astronomers aren't on board with the idea of the Big Bang, even. But one of the coolest new theories, do we live in a black hole? Is the edge of the observable universe actually our event horizon? Stay tuned, there's some cool new videos coming your way. Black hole dwellers, the oscillating universe theory, simple-minded astronomers or overly suggestive AI, the multiverse, and more. Thanks for tuning into this episode suggested by one of our amazing viewers. We love taking suggestions. Leave a comment below if there's something you want to hear more about. Join us on our journey through the cosmos. Catch you next time at Hidden in the Stars.